Okay. At the top of the next page, write greatest common factor. I'm going to show you two different ways that you can find your greatest common factor. The one way, the first thing you're going to do is list all the factors of the number. And this method is the easiest. It's the quickest. I would think it's the quickest. So the first thing you're going to do is you're going to list all the factors of the numbers. And then you're going to find the largest number that is in both sets. Okay, so let's say we want to find the greatest common factor of 24 and let's say 56. Okay, so for 24, the first set of factors of 24 are always, or the first set of factors of any number are going to be 1 in itself. So 1 in 24. Now, when Mrs. Feltman and I were your age, there used to be a cartoon on TV. And do you remember on the cartoon, it might have been Scooby-Doo, I don't know what it was, but where the walls would start closing in on the person or whatever?
Yeah, Scooby-Doo.
Was it Scooby-Doo? Okay. Well, that's what we do here. Okay? We have set up the walls. There's none going to be smaller than 1, and there's none going to be bigger than 24 for the number 24. Now, you take 24 divided by 2. 24 divided by 2 is 12. And so the walls have closed in a little bit. Now there's no more smaller than 2 and no more bigger than 12. You take 24 divided by 3 and you get 8. And the walls have closed in more. You take 24 divided by 4 and you get 6. And the walls have closed in even more. You take 24 divided by 5. Can you divide 24 by 5? No. You take 24 divided by 6. We already have the 6. And so there are all the factors of 24. Then we're going to do the factors of 56. Once again, the first set of factors are 1 and 56. So we set up our walls. Okay? None smaller than 1, none bigger than 56. 56 divided by 2 is 28. 56 divided by 3. If you take 56 divided by 3, does it work evenly? No, it won't. 56 divided by 4. If you take 56 and divide it by 4 in a calculator, you'll get 14. Can you divide 56 by 5? No. Can you take 56 divided by 6? No. 56 divided by 7. And 56 divided by 7 is 8. And now, the walls, there's no numbers between 7 and 8, so the walls are basically touched together. So, we've done step 1 where we listed all the factors of the number. Now step 2 is just simply find the largest number that is in both. Well, 24 is here but not down here. 12 but not down here. 8 is in both sets, and so the greatest common factor would be 8. And you're always going to see greatest common factor abbreviated GCF. Okay? So that is one way to find greatest common factor. But now we have to find a more difficult way. All right? And we're going to do this. We'll just do 24 and 56, and we'll use factor trees. Okay, so we're going to start off with the number 24. 24 can be broken into what?
4 and 6. 4 times
4
6.
times 6. 4 can then be broken into
2 times 2.
2 times 2. 6 can be broken into, Nadia?
3 times 3.
2 times 3. Now those numbers cannot be broken any farther. Okay, so we're in prime numbers. Now we're going to do the same thing with 56. 56 can be broken into
7 times 8.
Now we can't break the 7 any farther, but the 8 can be broken into
4 times
2 times 4. I bring that 7 down. The 4 can be broken into 2 times 2. The 2 can't be broken down, so we bring that 2 down. The 7 can't be broken down, so we bring the 7 down. Okay, so now we have done prime factorization. Now what we're going to do is we're going to pair up the numbers. Okay? There is a 2 here, and that goes with that 2. So I bring that 2 down. This 2 pairs up with this 2. So I bring that number down. This 2 pairs up with this 2. So I bring that 2 down. Now there's a 3 in this set, but there's not a 3 in that set. There's a 7 in this set, but there's not a 7 in that set. So we have all the pairs now that we can make, so now we multiply. 2 times 2 is 4, and 4 times 2 is 8. And so once again, 8 would be the greatest common factor. Okay, so when doing a factor tree, the first step is make a factor tree to get prime factorization. Step 2, how do you want to word it? Find numbers that are in both sets. Does that make sense?
Find equal numbers, maybe?
Not necessarily equal, but we want to find out what number is in both sets. So find the numbers.
Corresponding, maybe?
You can, if you want to put corresponding, that might make sense for you. Find the numbers that are in both sets and multiply them. Okay? Let's get out your boards once. Now, I think, like I said, I think this way, listing all the factors, is probably the easiest. However, they're going to ask you at different times to use prime factorization to find the greatest common factor, so we need to practice that as well. So, let's try 18 and 32. Yes?
We have 4 markers.
Okay, just use one of them. Okay, so I want this side of the room, I want you guys to do the prime factorization. I want you to do a factor tree of 18. I want you guys to do the factor tree of 32. If you need to, you shouldn't need it. If you need it, you can, but hopefully you know your multiplication facts good enough that you don't at this point. You're only doing 18, that's how I was doing 32.
Should we do the thing where we?
Just do the prime factorization right now and then just stop. Okay? Okay? So, 18. What can we factor 18 into? Blake? 3 times 6. We factor this any farther? The 6 breaks into 2 times 3. We can't break the 3 down any farther, correct? Okay, the 32. Parker. Without your calculator, what can you break 32 into? 4 times 8. Now the 4 can be factored into. The 8 can be factored into. And then the 4 needs to be factored into. And then I bring that 2 down, this 2 down, and this 2 down. Okay? So now, we have factored both those numbers. Now we want to find out what is common in both numbers, or in both sets. We have a 3 here, but we don't have any 3's there. We have a 2 here, and we have a 2 there, so I can bring that 2 down. I have a 3 here, but there's nothing else over there, so the only number that's common in both is simply 2. And so the greatest common factor of 18 and 32, or the greatest common factor would be 2. Okay? Erase your boards.